Okay, proceeding to question number 6. When completing the square for x squared minus 18x plus 77 equaling to 0, this equation right here, which equation is a correct step in the process? Okay, so let's work this out. The first step when it comes to completing the square is to get rid of this third term here. We want to get rid of this 77. We do that by moving it to the right hand side, and that is done by performing the appropriate arithmetic operation, and that will be done by subtracting 77 from both sides. If we go ahead and subtract 77 from both sides, we will see that we will have x squared minus 18x equating to negative 77. Now, in order to now continue with the completing the square method, I'm going to have to take this second term, divide that term by 2, square it, and then add it to both sides, both here and there. Let's go ahead and do that. So I take negative 18 and divide it by 2, and then I square it. In other words, so the way I can do this is the following. Negative 18 divided by 2 gives me negative 9. I square it, I get 81. So what I'm doing essentially is I'm adding 81 to both sides. I'm adding 81 here, and I'm adding 81 there. Again, this was done by taking negative 18, dividing it by 2, and then squaring it. That would give you negative 9 squared, which would come out as positive 81. And then that 81 would be placed both here and there. Okay. Then we can simplify this further. In order to write this out properly, we're going to rewrite negative 77 plus 81, which gives us positive 4. But on the left-hand side, we're going to condense this. This is the same thing as saying x minus 9 squared. All you need to do is just create the parentheses, then write the letter x, write the symbol square, and just take the second term divided by 2, and that's going to be the term that goes here. That's literally it, which makes choice 1 the correct answer, and the rest of them incorrect. So we can go ahead and highlight that. Okay, question number 7. Which function will have the greatest value when x is greater than 1? So for number 7, when x is greater than 1, let's make x equal to 2. So I'm going to use each and every single one of these equations and figure out what the value will be when I evaluate at 2, x for 2. So g of 2 is equal to 2 times 5 squared, which is the same thing as saying 2 times 25, which gives me 50. F of 2 is 2 times 2 plus 5, which is 4 plus 5, which gives me 9. H of 2 is 2 times 2 squared plus 5, equaling 2 times 4 plus 5, which is 8 plus 5, which gives me 13. And then, of course, k of 2 is equal to 2 times 2 to the third plus 5, which is 2 times 8 plus 5, which is 16 plus 5, which is equivalent to 21. So out of those four numbers, the largest value when x is greater than 1, namely when x is equal to 2 particularly, is g of 2. And that is connected to this exponential function, which makes choice 1 the correct answer. Just to note as a side fact, whenever you have an exponent here, the function is exponential. Whenever you don't have any exponent other than 1, meaning if the exponent here is just 1, it's linear. If you have an exponent of 2, it's quadratic. If you have an exponent of 3, it's cubic. Generally speaking, exponential functions, they increase and decrease very rapidly in comparison to linear functions. They can either go up very quickly or they can go down very quickly. And question number 7 shows you the equivalent values that we got. Okay, number 8. For number 8, we have the following. Mike uses the equation p equaling 1,300, parentheses 2.65, raised to the power of x, to determine the growth of bacteria in a laboratory setting. The exponent represents, so Mike is, trying to determine the growth of a bacteria. So this is presumably Mike's hand, and it's in a laboratory, that's why he's wearing gloves. And here's the bacteria. We want to know what the exponent x represents. So let's look at question choice 1. So here I've rewritten the equation. Notice that the total number of bacteria currently present represents this value right here, this whole expression here, which is equivalent to b. So choice 1 is actually the b value, not the x value. The percent at which the bacteria are growing are always in reference to the number inside the parentheses. So 2.65, that is the percent at which the bacteria are growing. So that has nothing to do with the x. The initial amount is the first number, which is 1,300. That's always going to be the initial amount. Because if I let the x value equal 0, then this whole thing turns out to be 1. And a number times 1 is just itself. And when x is equal to 0, this is known as the initial amount. So 1,300 is the initial amount, so that's not x. So leaving choice 4, the term that represents the x value. So the number of time periods is actually what the exponent represents. So in this case, choice 4 is the correct answer. Okay, number 9. A company ships an average of 30,000 items each week. The approximate number of items shipped each minute is calculated using the conversion. So imagine these packages here. Some guy has to be delivering it, either to your door, either wearing a mask or not wearing a mask, depending, if it's COVID or not. And everything's based on a clock, so time's ticking. So we need to figure out the appropriate conversion. So we have to understand certain key terms here. So it says items each week. So that means the item term will be on top, this term will be on top, and the week will be on the bottom. So we can automatically eliminate choices 3 and 4 because items have to be on top and week has to be at the bottom. The next thing we have to look is choice 1. Notice that if the same two terms are in the denominator on the same side of the fraction, then they will not be able to cancel out. And because they're unable to cancel out, they cannot possibly convert one unit to another. So this will not be correct. Now, if you go to question number 2, actually everything works out here because look, weeks will cancel out with weeks. Days will cancel out with days. Hours will cancel out with hours, leaving you exactly with items on top and minutes at the bottom, which is exactly what you want. You want items shipped each minute. So this each, think of it as the vinculum. So this is the vinculum. And in mathematics, the vinculum is basically this line that separates the numerator from the denominator. So think of the word each as the vinculum, separating the items which are the numerator from minutes, which is the denominator. Think of it like that. I think I should rewrite that much more appropriately. So this will be the numerator. Okay. Question number 10. A function is graphed below. Okay, so we have some curvature. Graph is going like this. It's interesting, looks like the letter N of the English alphabet. And what we want to know is a possible equation for this function. So in order to answer this question appropriately, we have to recall the fundamental theorem of algebra. Theorem of equations proved by Carl Friedrich Gauss in 1799. And what that theorem states is the following. It states that every polynomial equation of degree n with complex number coefficients has n roots, or solutions. In the complex numbers, the roots can have a multiplicity greater than 0. And in this case, we actually will have a multiplicity. So we have these roots here, all right? So wherever the graph crosses the x-axis or touches the x-axis is a root of the equation. So we have here at x equals -3 and here at x equals +2. So notice that we have the following. We have x equals -3 and we have x is equal to +2. Solve each one for 0, meaning add 3 to both sides. You'll get x plus 3 in parentheses is equal to 0. And subtract 2 from both sides, you'll get x minus 2 is equal to 0. Now, we would generally multiply them, so we have some sort of function. We call this function f of x. That is equal to x plus 3 times x minus 2. Now, generally we would be done here, but because this curve exhibits a cubic function, it is of the degree x cubed. So in order to have the appropriate equation, we're going to have 3 roots, and one of them has to be, in this case, a multiple. So which root will be the one that's multiple? It's the one that has a reflection, the one that bounces back up. So we'll put a square here because we have double roots for x minus 2. And so our equation will be the following. Choice 3, it'll be x minus 2 squared, because we have a duplicity here. And x plus 3, because we have the line, the curve passing through the x-axis. So one way you can think of it is the following. Since the graph passes through the x-axis, it's 1 point here, and since it deflects or reflects over the x-axis, you can have 2 points here. You can think of it like that, if that helps. Okay, question number 11. If g of x is equal to negative x squared minus x plus 5, then g of negative 4 is equivalent to what? Okay, so this process needs to be evaluated.
Exhibit.
This process has to be done in the appropriate way. So what we're going to do is we're going to replace x with negative 4. So we have g of negative 4 equaling negative parentheses negative 4 squared minus parentheses negative 4 plus 5. So that gives us negative bracket 16 plus 4 plus 5, because negative times a negative will equate to a positive. Then we have negative 16, we're distributing the negative inside, plus 4 plus 5. Well, that gives us negative 12 plus 5, which gives us negative 7. And then I can just keep rewriting g of negative 4. G of negative 4. So we know that g of negative 4 now is equivalent to negative 7. So we can go ahead and highlight that. Okay, now let's go to question number 12. For question number 12, it says the following. A movie theater's popcorn box is a rectangular prism with a base that measures 6 inches by 4 inches and has a height of 8 inches. So let's look at the scenario here. So we have a box that is 6 by 4 by 8. The height here is 8. Okay. To create a larger box, both the length and width will be increased by x inches. So we're talking about the base. The base will be increased. So we have 6 plus x here, 4 plus x here, but the height will remain the same. The height won't change. So we'll have, imagine the height being like this. Same height. So the height remains the same, it doesn't change, but the base does. So we'll neglect the top portions here. Imagine this part didn't exist. So the volume will be now the following. We know that the volume of a rectangular prism is length times width times height. So the volume, let's call it v of x. So the length is added by 6. So by x. So we have 6 plus x. The width of the larger box, because we're looking for the volume of the larger box. The width is also added an additional value of x, and then the height remained the same. So which equation corresponds to that? That would be choice 2. So go ahead and highlight that. So that's choice 2. Okay, moving on to question number 13. Question number 13, many found to be extremely easy, and the reason why is the following. Well, in this particular question, we have the following. The expression 300 times 4 to the power of x plus 3 is equivalent to what? So here we have 300 times 4 to the power of x plus 3. What I want you to do is I want you to just focus on this part right here. Notice that we can break this apart. We can say the following. We can say that this is the same thing as saying 4 to the power of x times 4 to the power of 3. That is because when we multiply two terms with the same base, we add their exponents. So and then I can place this back into parentheses, and that would correspond to choice number 1. Now be careful, many make the mistake of saying that it is choice 3, and that's not true. We don't multiply 300 to both of them. Everything's being multiplied. There's no need to multiply to both terms and then add them. Okay, number 14. Ashley only has 7 quarters and some dimes in her purse. She needs at least $3 to pay for lunch. Which inequality could be used to determine the number of dimes D she needs in her purse to be able to pay for lunch? Okay, so first of all, we need to know what at least means. So whenever you deal with the word at least, that means greater than or equal to. Right. Okay, so what we want to do is now determine this. So she actually has 7 quarters, right? How much is 7 quarters? So each quarter is 25 cents. When you multiply that to 7, you get $1.75. So she has 7 quarters, which is essentially saying $1.75, and some dimes in her purse. Well, a dime is equivalent to 0.10 cents, right? That's what a dime is. So she needs at least $3 to pay. So she already has $1.75. She has some amount of dimes we don't know, but we know that the denomination of the dimes is worth 10 cents. So we can say 0.10D. And it has to be at least enough to pay for the lunch, which is $3. So we can say greater than or equal to $3. And that's it. And so the one choice that corresponds to that is choice 2. Okay. Number 15. The formula for the area of a trapezoid, A equaling 1/2 base 1 plus base 2 times height, the height h of the trapezoid may be expressed as. So when it says the height, what we want to do is we want to solve for the height. So let's go ahead and look at this equation. And the first thing you're going to do is you're going to multiply both sides by 2. That's the first thing you're going to do. You're going to multiply both sides by 2. By multiplying both sides by 2, the equation now becomes reduced to the following, or transformed. 2a is equal to base 1 plus base 2, of course, still in parentheses, times height. The next thing you're going to do is divide both sides by base 1 plus base 2. Base 1 plus base 2, because again, you're just looking for the height. So this cancels with this. And now you have the height equaling to twice the area divided by the sum of both of those bases. And so which expression is equivalent to that? That is choice 4. Okay. Number 16. For number 16, you have to read the question carefully. The function f of x is equal to the absolute value of x is multiplied by k, which is a certain constant, to create the new function g of x, which is equal to k, absolute value of x. Which statement is true about the graphs of f of x and g of x if k was a half? Okay. Whenever you have a fraction for your constant, right, the graph of g of x, the one you're multiplying the half to, will become much wider. So g of x, so the answer here is actually choice 3. G of x will be wider than f of x. On the other hand, if the k value was, let's say, 2, right? Let's say 2 over 1. Then this would be wider. Narrower. This would be narrower. If k is a fraction, then it would be wider. So that's basically the gist of it. Again, another way to do this is actually to graph, and you'd see this. So, for instance, let's say we had this graph here. Okay. So the f of x function would be like this. That's the absolute value. So let me just draw the absolute value. Let's label our y and x. Okay, this is the absolute value function. This is f of x equaling the absolute value of x. Now, if we want to get g of x, it would be much more like this. This here would be g of x, which would equal to 1/2 the absolute value of x. If k is 1/2, it'd be much more wider. So it'd be like spread out more. Okay, number 17. Some adults were surveyed to find out if they would prefer to buy a sports utility vehicle, which is an SUV, something like this, or a sports car, something like this. The results of the survey are summarized in the table below. Of the number of adults that preferred sports car, approximately what percent were males? So we want sports car. So we have what percent were males? So we have 38 over a total of 84. So we go on 38, we divide that by 84. So I guess you can simplify this further. Divide both top and bottom by 2.